Hello and welcome to Los Alamos National Laboratory's Math and Science Academy. In this thread we'll be exploring the Grade 5 Common Core Math standard that involves dividing unit fractions by whole numbers and also dividing whole numbers by unit fractions. There are three examples involving this standard. The first one will be dividing a fraction, 1/2 pound of chocolate, by a whole number, 3 people. In the second example, we'll talk about dividing a whole number, 2 cups of raisins, by 1/3 cup, a fraction. And then finally, in another example, we will show dividing a whole number of cups of milk by a non-unit fraction, 3/4, and see what that brings up. The learning goals include being able to translate a word problem into an associated mathematical task, and then visualize and understand dividing a unit fraction by a whole number, dividing a whole number by a unit fraction, and then putting those together to understand dividing a whole number by a non-unit fraction. The student will also need to fluently use multiple strategies to understand parts of whole numbers, fractions of whole numbers, that is, area models, number lines, and symbols, and the student needs to be able to communicate mathematical thinking with precision. So for this standard, we'll be doing 3 different problems of increasing complexity. We'll start with the question, how much chocolate will each person get if 3 people share 1/2 pound of chocolate equally? You'll notice that the number 3 comes before the number 1/2 sequentially, so students who see this as a procedural problem of division may get it wrong. They may divide the first number, 3, by the second number, 1/2, and just keep going. It's important that they really understand the meaning, because what we need to do here is divide 1/2 pound of chocolate among 3 people. We have a fraction divided by a whole number. So for this example, we can use concrete visualization because students have some experience with chocolate. So here's a pound of chocolate. If we break it in half, this is the amount that we have, 1/2 pound of chocolate. And we're going to divide that evenly among 3 people. So each of them will get 1/3 of the 1/2. So what we're after is 1/3 of 1/2. But now we need to change the units into pounds, and so we really want to know, what does this part here represent relative to the whole pound of chocolate? To do that, we'll divide the other half into the same unit fraction that we have here, 1/3. So now we have divided the piece of chocolate into 6 equally sized pieces. It's important that these pieces, of course, all be equal in size. And now, just visually, we can see that what used to be 1/3 of 1/2 is 1/6 of the chocolate. And in other words, it's 1/6 of a pound of chocolate for one piece. And that's how much each person will get. Of course, this will get a lot easier for your students if they visualize chocolate that's broken into pieces. Very often students will have an idea of chocolate bars already broken into pieces, hopefully in numbers that are consistent with the problem that they're doing. Okay, so here's our problem again. How much chocolate will a person get if 3 people share 1/2 pound of chocolate equally? In our previous example, we used a very concrete image of chocolate itself. In this case, we'll be a little more abstract and use an area model. To do this, we'll let a rectangle represent 1 pound of chocolate, in which case 1/2 pound is half of the rectangle. This is the amount of chocolate that we have to divide up between our 3 people. If we want each people to get an equal share, we'll divide this 1/2 pound into 3 equal parts, and we can see visually that each person will get 1/3 of the 1/2 pound. The question is, however, what part is this portion of a pound? The question implicitly asks how much. They're talking about how many pounds of chocolate does each person get. So to do this, we need to break the rest of our chocolate, this other part, into equally sized pieces as well, to see then that out of the pound, one of these portions represents 1/6. There are 6 equal parts to the pound, and therefore one portion is equal to 1/3 of the chocolate, but 1/6 of a pound of chocolate, which is your ultimate answer. So this can be confusing to students because there are two different kind of divides going on, or two different wholes. If students are thinking of fractions as a part out of a whole, we've got 1/3 of a half, where the whole is all that is the chocolate that we have available, and so the whole is really the half pound. But in the bigger formulation, the whole is the pound of chocolate, and we're dividing that into 6. So this switch of what represents the whole can be a confusing concept for students. Notice again, as in every case, we try to make use of images to support the concepts and really use precise language to ultimately get to procedures. So here's our problem again. How much chocolate will each person get if 3 people share 1/2 pound of chocolate equally? In this case, we'll go through it using a procedure. In any procedure, the first thing that's necessary is to really understand and identify the core or key idea in the problem. And in this case, the key idea is that we need to divide the chocolate by the people. Even though the number of people comes first and the number of chocolate comes second, we're going to divide chocolate by people, not just first number by second number, which is a common pitfall if students are not really reading and understanding the question. So what we have is a fraction divided by a whole number. This is what we need. So the next step is to identify what we know about division of fractions. So this is a fact that students need to know, that division is multiplying the dividend by the reciprocal of the divisor. In other words, we're going to take this 3 and take the reciprocal of it and multiply by 1/2. So here we go, 1/2 divided by 3 is the same as 1/2 times 1/3. And then another combination of procedure and facts that students need to know is to multiply fractions. We multiply the tops, the numerators, and the bottoms, the denominators. And so in this case we get 1 for the numerator. 1 times 1 is 1. And in the denominator, 2 times 3 is 6. It's a simple fraction. There's no reducing or any common factors to deal with, so we get our answer 1/6. You'll notice how procedures are built on previous procedures and lots of facts and language. So facts, language, and procedures kind of all work together and build on each other, but they're not of much use at all if we haven't introduced things through images and concepts. So that's what we need to tie together, are the images and concepts behind what's going on with the facts and language and procedures that ultimately make it most efficient. At the end, we see that each person gets 1/6 of a pound of chocolate. So here's some teacher work that's associated with this problem. You'll notice that in the first formulation, the teacher has simplified the problem a little bit. Instead of talking about a half pound of chocolate being equally split, the teacher has simplified it and just said Pat has a candy bar. So this is kind of a warm-up problem to help the students remember that when you divide something into 3 equal parts, you get thirds. And then presumably the next task would be to bring this up and now talk about the thing that is being divided is, instead of a whole, is a half itself. So this is kind of a warm-up version of things. Over here we have another interesting formulation. The problem is written here, 3 people share 1/2 pound, and it's clear that the procedure that needs to be done is recognized. 1/2 has to be divided by 3 people. But to do this, the teacher takes an interesting twist. Recognizing that 1 pound is 16 ounces means that a half a pound is 8 ounces, and they convert the chocolate bar into 1 ounce parts. But interestingly, these are eighths. There are 8 parts, and 8 is not evenly divisible by 3. So it actually introduces a little bit of a confusion, perhaps, but it also introduces depth because you can do it this way. Here are the 8 ounces here, and if we're going to divide by 3, then we know we can have three groups of 2 complete, and those are these. So each student will get at least 2 ounces, and then we have these 2 ounces here remaining, and they need to be divided up evenly by 3. And to do that, the teacher divides each of these ounces into 3 equal portions. So here's 1/3 of an ounce, and then our 3 people each of them gets 2 of these thirds. So each of our 3 people who are sharing the chocolate get 2 and 2/3 of an ounce. And this is a perfectly good answer. It's a little bit awkward because the problem begins in units of pounds, and so it would be helpful to be able to change 2 and 2/3 ounces into some number of pounds. It's not exactly evident how that happened in the work here. Presumably this picture is helping the teacher to understand it, but it's not exactly evident what they're doing. But it's important to notice that there's another approach, a correct answer, and then the possibility of converting 2 and 2/3 ounces into 1/6 of a pound. However you want to help students understand that. So again, you've seen a lot of images here, some underlying the concept of dividing by 3, facts of arithmetic and language, and possibly even a little procedural work here, depending on how exactly the teacher chooses to explain that. So here's an example of some mathematical writing that we might get from a student. You'll notice that it has a different conceptual underpinning than the previous examples. The student has basically recognized that if you doubled the chocolate, you could give the same amount to 6 people. In other words, dividing a half a pound of chocolate by 3 people would be the same as dividing a whole pound of chocolate, doubling it, by twice as many people, 6. And if you divide a whole pound of chocolate by 6 people, then each would get 1/6 of a pound. So this student has done a lot of intuitive thinking about the problem, but has still written down here using good language exactly what they're doing in order to come up with the correct answer.